Hi, awesome pre-cal students. Before we begin today's notes, I think we need to recall a couple things. For instance, a negative exponent. A negative exponent means the reciprocal of the base. The base is 2. The reciprocal of 2 is 1/2. We've taken care of the negative, so now it's 1 over 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. So we get 1/8. The opposite of that would be if our base is a fraction, the reciprocal of that fraction would be 5 over 1, and now it would be to the positive 2 power, and we would simply get 25. The next example, when we have a fractional exponent. A fractional exponent means you have a radical. We have 125 to the 2/3 power. The top number is the exponent, the bottom number is the root. So this is actually the cube root of 125 squared. So we'll do the cube root first. The cube root of 125 is 5, and 5 squared is 25. And now the opposite of that would be taking it out of radical form and putting it in exponent form. So the 3 would be the exponent and the 4 would be the root number. So that would be 3 to the 3/4 power. There we go. So we took it out of radical form and we put it in fractional or rational exponent form. All right, now let's start. I feel like our notes pretty much parallel our delta math today. So if we can do the notes, we should be fine on the delta math. We'll start by solving. It says to solve for x. We're going to solve for x. We'll start by taking this out of log form and writing it in exponential form, starting at the base of 7 to the x power equals 49. So one way you can solve this, if you don't know 7 squared is 49, you would rewrite 49 with the same base, which is 7 squared. When your bases are equal, your powers are equal. So we know that x would equal 2. Same thing, only the x is in a different position this time. We have x to the 3rd power equals 1,000. X to the 3rd power equals 1,000. So what we want to do, if you don't know it's 10 to the 3rd, 10 to the 3rd does equal 1,000. If you don't know it's 10 to the 3rd, then rewrite 1,000 as 10 to the 3rd. Now this one, when the exponents are equal, the bases have to be equal. So x is equal to 10. The next problem, 9 to the 4th power is equal to x. 9 to the 4th is equal to x. We'd probably need our calculator for that. This is just the calculator from my computer calculator. 9 to the 4th power equals 6,561. So we would just take out a calculator to do that. And again, the x is in a different position. In all three of these problems, x was in a different place. Part 2. Now we want to do the same thing. Take it out of log form to solve. 7 to the x power is equal to 1 over 343. 7 to the x power equals 1 over 343. So again, we want to get our bases to be equal. So 7 to the 3rd power is equal to 7 to the 3rd power is equal to 343. Again, we could bring up our calculator. We could do 7 to the 3rd power equals 343. And now that we have 1 over 7 cubed, we would rewrite it. That would be 7 to the -3 equals 7 to the x So x is equal to -3. So we're taking these out of log form and writing them in exponent form in order to solve them. We have 1/27 to the -2/3 power equals x. You could do this in a calculator, or you could solve it. You can completely do this in a calculator, but I'm going to solve this for you. First, I'm going to take care of my negative by flipping 1/27 over. So I would have 27 to the 2/3 power equals x. Now I'm going to put it in radical form. This would be the cube root of 27, and whatever I get, I would square it. Remember, your top number is the exponent, the bottom number is the root, like words end in ER. So the cube root of 27 is 3, and 3 squared, of course, is 9. So 9 equals x. Or you could use a calculator and find that answer in the calculator. The next problem, x to the -5 is equal to 1/32. X to the -5 power is equal to 1/32. So I took it out of log form, wrote it in exponential form. So we'll continue. X to the -5 power is equal to 1/32 is 2 to the 5th power. Now you might need a calculator to figure that out. 2 to the 5th is 32. So all I did was rewrite that, 2 to the 5th. I'm going to bring it up from the bottom. So I have x to the -5 power is equal to 2 to the -5 power. If I bring 2 to the 5th to the top of the fraction, it would be 2 to the -5. Again, if my powers are equal, then my bases are equal. So x is equal to 2. Next problem, we've got x to the -2/3 power is equal to 1/9, equals 1/9. Okay, so let me do this one a little differently. Let me raise this. I remember now why I picked this problem. Let me raise this to the -3/2 power, because raising a power to a power, we multiply the powers. If I multiply -2/3 times -3/2, I just get x to the 1st. Of course, what I do to one side, I've got to do to the opposite side. So I'll raise the right side to the -3/2 power. The negative is just going to flip 1/9 over and make it 9 to the 3/2 power. The bottom number is the root, and the top number is the exponent. So that would be the square root of 9, and whatever I get, I would cube it. So the square root of 9, of course, you know the square root of 9 is 3, and 3 cubed is 27. So the final answer is 27. Or you can use your calculator to put that in a calculator. Next problem, we have taking it out of log form. We have natural log. We know that the base is e, so that's e to the x equals the 4th root of e. E to the x equals the 4th root of e. So e to the x equals, I'm going to take this out of radical form. I put my exponent over my root, so that would be e to the 1/4. When my bases are equal, my powers are equal, so x is equal to 1/4. X equals 1/4. And done. Next one, 16 to some power is going to equal 1/4. 16 to some power equals 1/4. Well, I know 16 is 4 squared. So all I've done is rewritten the 16. And I know 1/4 is the same as 4 to the -1 power. And a power to a power, power to a power, we multiply the powers. When our bases are equal, our exponents are equal, and we solve for x and we get -1/2. All right, the next problem, it says don't solve this, just write it in exponent form. We'd have 3x plus 2 squared equals 3. E to the 4th equals 3x minus 1. And 10, when there is no base, it's an automatic understood base 10. 10 to the 2x minus 3 power is equal to 3. Okay, so that kind of sets us up for this last example where we are going to solve. It says x plus 4 squared is equal to 3x squared minus 6. X minus 6x. All right, on the left-hand side, we're going to have to square that. So let's write it out twice. X plus 4 squared means x plus 4 times x plus 4 equals 3x squared minus 6x. Let's FOIL. X times x is x squared plus 4x plus 4x plus 16 equals 3x squared minus 6x. On the left side, we get x squared plus 8x plus 16 equals 3x squared minus 6x. We're going to create a little extra room. We're going to have to factor, so let's get everything to one side. Let's subtract x squared, subtract x squared. While we're at it, let's subtract 8x, subtract 8x. And we may as well subtract 16, subtract 16. So we end up with 0 equals 2x squared minus 14x minus 16. We always look for a GCF first. If we could factor out a GCF, which we can, factor out the 2. Look for two numbers that multiply together to give us -8, but they would add together give us -7. So I feel like that would be a -8 and a +1. So x equals +8, x equals -1. We have a minor issue. Remember that whenever working with logarithms, the base and the number that comes after the word log are always positive numbers. So I'm concerned especially about this one. If I plug it back in, will I have a negative number in the base? If I plug in -1, that would give me 3 in the base, and this would be negative. This part of it would be negative. Oh, no, it wouldn't. No, that would be positive. No, we'd be fine. I think these are both going to be fine. I know 8 will be fine. Yeah, good answers. Okay, your homework tonight is a Delta Math. It's called Solving Logarithmic Equations Day 1. Y'all have a great day.